of x is f of x divided by g of x. What is h prime of x equal to? Okay, and I don't know, for some reason I like to put that one first. So that one times that one. You guys still do the low d high minus high d low? I always just say, I know it's a good way to memorize it, but I always just think how I learned it when I was in high school is the derivative of the first times the second minus the derivative of the second times the first, which is the same thing, but that's just my thing that I can get in my head because that's how I learned it, over the bottom squared. Right, so there's low d high minus high derivative of the low over the low squared. So if you want to find for part 3 h of 1, then you just need to come and put a 1 in all of these and figure out what that equals. And then you just get that off the table. So just look at the table, f prime of 1, negative 2, g of 1, 1, g prime of 1, 2, f of 1, 4, over g of 1, which is 1, squared. A little bit harder. The thing you have to remember is on this one, this is your outer function and f of x is your inner function. So you just have a squared function with a function inside it. So you have to do the chain rule. Derivative of the outside times the derivative of the inside. So on this one, h prime of x, what's the derivative of something squared? 2 times that something. So I'm doing 2 times f of x, and then you do the derivative of the inside. The derivative of the inside is, and now you just need to plug in 4 into all of these and find it. Probably the hardest part is just plugging in the numbers, or finding the formula to plug in the numbers. So I'm not going to finish that one. I'll let you guys plug them in. So how do I do this part? I have a function, and then inside that function I have another function. So it's the derivative of the outside times the derivative of the inside. Well, what's the derivative of the outside function? So it's the derivative of f of x, or f of something. F prime of something, you just have to leave that something inside, times the derivative of the inside. Okay, so on this one, if you want to plug in 4, this is the tricky part, is plugging in 4 into this first part. Because I have to plug in g of 4. So I look at g of 4. G of 4 is 2. So now when I get over to the f, I'm plugging in 2 into the f prime, not 4. Because you have to find out what g of 4 was and then plug it in. So now I have f prime of 2. F prime 2 is negative 1. G prime 4, 1. Negative 1. But you just kind of have to get used to doing it kind of symbolically. You know that it's the derivative of the outside times the derivative of the inside, or the chain rule, or the product rule. As you go to find dy dx, just remember y is a function of x. So if you take the derivative of y, you have to have the outside function. So the outside function would be 5y cubed. You also have to take the derivative of y. Y is the inside function. So starting, what's the derivative of 3x? 3. And now just the derivative of the outer function, because this y is a function of x. How do I do the derivative of 5y cubed? But after you do that, every time if it's the derivative with respect to x and it's not an x, it's any other variable, you have to times by like dy dx or y prime. And so on this one, the thing to realize too is that it's a product rule. So you have to do the derivative of the first one times the second plus the first one times the derivative of the second, and the derivative of y prime equals the derivative of 2. And now you got to solve that for y prime. So get y prime by itself on one side, factor it out. So I'm leaving all the y primes in terms of y prime on one side and moving the other ones to the other side. Now we're almost done. We just need to separate the y primes. So factor. And then divide. And when you guys take your test, it will be matching. So if this doesn't look exactly like it, you've got to decide which one it is, because I don't think this is exactly probably, I was going to say there's 3's and everything, but the x cubed does not have a 3 in it. Okay, so it should look something like that for your answer. That simplifies down. Realize some equivalent expressions to this. This is the same thing as if I put a -1 on top and bottom, which you would never leave it like this. But this could be the same thing as maybe the answer on a test would look like -2x, and then it would have y minus x. So you got to be able to see that this and this are the same thing, or that this one and this one are the same thing. So if it has the opposite of both of them, all they've done is times both things by -1. So don't forget that concept, that those are equivalent. So we're going to start with this function f of x equals the square root of x minus 4. And we are going to find, just to start with, we're going to find the inverse of it. So we're going to say g of x is the inverse of x. Just because it's kind of hard to do f inverse derivative, because we already have something there. So let's find that. First off, I guess, what is the domain of this one? What x's can you plug into this without getting imaginary numbers? Anything 4 or above, right? And the range of this one is, what's the y values that you get out? If I plug in 4, I get 0. And then if I plug in anything bigger than 4, I just get positive numbers. So this is 0 to infinity. Let's graph that before we do the inverse of it. So let's just graph that one. So square root functions look like a sideways parabola. Remember that? So if I just plug in some points, when I plug in 4, I get 0. When I plug in 5, I get 1. You guys have been very helpful. What's another good number to plug in? So I can take the square root of 8. 1, 2, 3, 4, 5, 6, 7, 8. If I plug in 8, I get 2. And we might as well plug in the next one. 13. Okay, so we have 13, it's our wait. 4, 5, 6, 7, 8, it's at 2, and 13 it was at 3. That's probably good. This is what this looks like. And let's just write down some of those points. So we have that. So this will be 5, 1. I guess we can write down all of these. 4, 0, 8, 2, 13, 3. Without finding the inverse, we can find it algebraically, but without finding it, do you guys know what it looks like? It's a parabola, but it's only part of a parabola, right? Because it has to be exactly the same. What about the picture of it? Geometrically, what does it look like compared to that one? But what's the relationship? How can I start plotting some points without even finding it? Okay, it is reflected over y equals x, yes, because you switch the y's and the x's, so it ends up reflecting over that. So you have this line of reflection right here. Okay. And then, can you guys graph it from here? Like, what would be the points that would go with it? Okay, 0, 4. What one goes with this one? 1, 5.
8, 2, 8.
6, 7, 8. 8. Okay, so if I want to graph this, I could graph this 13, 3, 1, 2, but it looks something like this, right? Okay, I'm going to get rid of those lines. Okay, let's find the inverse. So what would the inverse be? I have, how do you find the inverse? If this is your function, how do you go about finding the inverse? Okay, that's it with the y and x. So the first process is switch the y and the x, right? And now how do I get it to say y equals? Okay, so y equals x squared plus 4. So g of x would equal x squared plus 4. Now the only thing, technically, to make it be the actual inverse, is we got to make sure the domain and range are the same. So this function right here includes the other side of the parabola. So you just have to make sure that you said that, I mean, you don't have to say what the range is, but you do have to say what the domain is. And this should be the domain of this. So if this range is from 0 to infinity, this domain has to be, the x has to be greater than or equal to 0. Which is what we've graphed, right? This parabola, but only from 0 and above. Okay, the thing I want you guys to do next is two things. I want you to find on f of x, I want you to find f prime of x, and after you find f prime of x, I want to look at the relationship between 2 points that correspond between inverses. So we're going to look at this point right here. I want you to find the slope of the tangent line right here at 1. And after you do that, I want you to find g prime of x, which is this one right here. And I want you to find the slope of the tangent line at, now this time, on this function, the one that corresponds to it is this point, right? These two are the reflections of each other. I want you to find g prime of 5. And we're going to see what that is. So find both derivatives and then plug in those values and find out, sorry, this is supposed to be f prime of 1 and g prime of 5. No. Yes, I switched. I just had this one by this one, but remember this one is f of x is this one. So I want to find f prime of 5, because this is the one that goes to this one. And I want to find g prime of 1, because that's the one that goes with this one. Oh, sorry, that was that. Okay, so I was going to on this one, just make sure I wrote, it's going to be easier to think of, right, if you have x minus 4 to the 1/2. So hopefully you guys are going to get at taking the derivatives of square roots. So what do you do to find the derivative then? What do you guys do? Okay, so yeah, so you negative 1/2, and then that just ends up being the square root on the bottom, right? So the 2's the denominator. So there's that derivative. This one was easy. 2x. So this slope was 2. This one was 1, 2 times square root of 1, 1/2. So the slopes, this one was 1/2, this one was 2. Now that we have the derivative, let's just do another one. Let's do, on this little function, f of x, let's do f prime of 8. Let's find the slope at this point now. So 1 over 2, 8 minus 4, so 1/4. Alright? And this one, what I have to plug in to correspond to that point right there. Plug in 2. 2 times 2 is 4. Okay, so every single time this is going to be true, and sometimes it's easier maybe to find the inverse and then just plug it in, but sometimes it's nice if you just can find the function and plug it in. So I was just going to say that the reason it works that they are reciprocals is because when you find the inverse, you do change the y's and x's. So the slope right here of this tangent line is rise over run, which is the change in y's over the change in x's. But when I switch it and do the inverse, it's going to have this change in y over change in x's, but they're just going to switch. If this one's change in y over change in x, this one ends up being compared to that one, change in x over change in y will be the slope on that one. That's going to be confusing to look in. The ones on your homework are not like this. They say things like, all right, here is my function, f of x, and I want you to find g prime of 13 equals, and you know you have these same functions, but you want to find g prime of 13. Well, we know what the g prime of 13 goes with 3, so it would have to go with this point up here, 313. But what if you didn't know that? How would I find it? What if I said, I mean, we know the functions, but what if I said something else? Okay, so I'm going to change this to 20. What about if I want to find g prime of 20? So I know, and let's say that I don't want to find all this. I mean, right now I could just be like, oh, g prime of 20, plug it in right here. Well, let's say I wanted to do it without finding this part right here. Let's say I only had this f function, and I knew that f of x and g of x were inverses. So for g20, I know that 20 is the x coordinate, but I don't know what the y coordinate is yet. I mean, I could plug it in to find it, but I don't know what g is. And for f, all I know is that the y coordinate is 20. And our f of x was the square root of x minus 4. So all I have so far, let's pretend like this is the only thing I have. I don't know all this other stuff. I know that f is the function square root of x minus 4, and I know I want to find g prime of 20, and I know that f of x inverse equals g of x. So g of x is the inverse. I know this. How can I find out what I need to plug in to do the reciprocal of? Okay, at some point I'm going to have to do the derivative of f of x. So I'm going to have to come up with the derivative of f of x for sure. But how do I know what x to plug in right here? Because I need this x right here. How can I find that x? Seems like a hard question, but really it's not. So I don't want to do f prime of all white. So the relationship is you've got to look at the points. So I can't just do f prime of 20 or let it equal 20 because we don't know what the slope equals. We only know the point. We're trying to find the slope. So if we knew what the slope equaled, we could just do the reciprocal of it and be done. But this is, how can I find the x coordinate? I have these two things right here. I have this. Whoops. I have this and I have this. How can I find what goes right here? Yeah, plug in 20. Where am I plugging in this 20? I have 20 equals the square root of x minus 4. So the point I'm going to do is just, it's somewhere, the y coordinate of f. There's, this one right here is 20. Okay. Or actually it's this one, huh? This is f, I keep getting confused. This one's f, the y coordinate of this is 20. It's clear up there, it's clear to the right. It's a big, huge number clear out there. So, to find the x coordinate, I square it and solve it. So 400, oh my gosh. 400 equals x minus 4. So what is my x coordinate? 404. So this is 404. So right here, I mean, it's not anything I really need. But when I plug in 20 into g, you would get 404 because they are just the x's and the y's switched. So if I want to find the derivative of g at 20, what do I need to plug in to my f prime? 404. So I get 404 minus 4, 2 times 20 is 40. So then you know, because of that, that g prime of 20 must equal the reciprocal 40. Now, the only reason this is kind of a bad example is because finding the inverse and plugging it in probably is easier. But sometimes it's hard to find the inverse, and the derivative of the inverse is sometimes ugly. I mean, we could find the inverse and then find the derivative of the inverse and then just do it that way. But this one will be way more simple if we just don't do it that way. I'm going to kind of write f over here and g over here. And I know on g that I want to find the point 30 something. Right? And on f, I need to find the corresponding point that goes with that. It's going to be something 30. Because if I can find f prime of 30, g prime of 30 is just going to be, not f prime of 30, f prime of something is going to be the reciprocal of this one. So I've got to figure out what to plug in so I can find the slope. So I know that my y coordinate on the f is 30. Now you just have to solve for the x coordinate. Plug it in, right? Is that okay? Is that making sense that you just have the y coordinate, you need to find the x coordinate. So everyone solve this equation, probably an integer. Okay, so I know that this must be the point, and I just kind of like to write this because it makes me feel like I'm keeping track of things. You don't have to write that, but if I know this is the point 230 on F, point 230 on F corresponds to the point 32 on G, and I know that I just have to plug in 2 on F, and that should be the reciprocal of plugging in 30 on G. Because those points, wherever the function is, it's going to be the reflection of it down there. Yeah, I just skipped a couple steps. Okay, but now I need the derivative of F, which this one is way easier, right? The derivative of this one, 12x squared. Well, now that's easy to plug in.
Wow, that was a lot easier.
Cosine square. 48, so this one should be 1 over 48. Okay, before I let you guys work on homework, I want you to see the difference. I want you to come up here and I want you to do it the other way. I want you to come here and find what g of x equals, the inverse of this, find the derivative of that, and plug in 30. And see if you can get 1 over 48. That'll be good practice finding the derivative of whatever this inverse is, which will have a cube root 1/3 power. It'll be kind of a pain, but just realize you can do it both ways, but sometimes knowing that relationship is going to be way faster. So do that and then start working on your homework. So notice on this one, the only difference, once you find it, you can either choose to write this like this. So part of the time I'll probably leave it like this when I find the derivative. But remember, when you're finding the derivative of the inside function, this is just 1/4 x plus 1/2. So the derivative of the inside is just 1/4. So you don't have to do like the product rule, or sorry, the quotient rule. It's just the derivative of 1/4 plus 0, or 1/4 x. One thing I want to point out about inverses, okay guys, just for 1 second, sorry, I know I have you doing something, but come back for just a second. Riley, wait a second. On this, notice the inverse. If you were to plug in something for x, what would you first do to evaluate that? You would cube it, and then multiply by 4, and then subtract 2. Well, notice what you do with the inverse function. If this is the inverse function right here, if you plug in something, Mariah, quiet please. What do you do when you plug in an x right here? You would add 2, divide by 4, and then cube root, right? Notice the relationship between these inverses. If you go exactly backwards, if this is what you do to it to get to here, if you want to find the inverse, it's exactly the opposite, and it undoes it. Instead of subtracting 2, you start at the end, you add 2, and instead of multiplying by 4, you divide by 4. Instead of cubing it, you cube root it. So they do have that relationship that you can kind of check. Do you guys remember last year that when you had to, if you plugged them into each other, what happened? Like this one, whatever, for G, you would add 2, divide by 4, cube root it, and then you plug it into here, and it exactly undoes it. So you end up with the same thing you started with. You guys remember having to do that? Okay. How far did you guys get on the derivative? Did you find the derivative of that one yet?
Yeah. Well, no.
Yeah, that's where you guys stuff.
It's like 3 over.
G prime of x. What do you do to find the derivative of this?
All of it 1/3.
Okay, you put a 1/3 out front, and then it's to what power? 2/3. 1/3 minus 1 is 2/3. And then I have that, just leave that the same. So that's the derivative of the outside, and then what's the derivative of the inside? What's the derivative of this inside function? 1/4. So you wouldn't even have to times it out if you didn't want. Like, I wouldn't simplify it any more than that. I would just now plug in, if I wanted to find g prime of 30, I could put the 1/3 and 1/4 together to get 1/12. But then you just plug in 30 plus 2 divided by 4,
What do you mean to find the derivative?
negative 2/3. What's that?
What do you mean to find the derivative of x plus 2 over 4?
Oh, the derivative of x plus 2 over 4 was just 1/4, because that's this right here. Yes.
How would you find like g prime of x from f prime of x?
When you guys get done with this, you can do it by hand or you can plug in the calculator. This should be 1/48. Kind of ugly, but I guess it's not hard to take the cube root of 8, right? It's just 1/12
That says one
cube
half.
root of 8. Oh yeah, 12 to the cube. And then negative. So you do the cube root of 8 and then square it. So 2 squared is 4, so it is 1/48. But that was way harder than just doing that, right? Sometimes it just depends on what function it is and what the derivative is. But just realize that relationship between them.